Welcome to solverfy.
In the following problem, we have an electron which is present in a one-dimensional infinite potential well. The electron exists in the ground state, which is n equal to 1 of the well. We need to find out the wavelengths of the photon that would amount to the longest wavelength, second longest, and third longest for the transitions. Now in this case, let us write down or draw n equal to 2. This is the first excited state corresponding to the second level. Similarly, a third level and a fourth level. So this is 3 and this is 4. Now we know that the transition from level n1 to n2, let us say that this corresponds to a certain energy which is E1 to 2. And then we can say this as E1 to 3. And similarly, we can say that this transition where the electron jumps from the first level to the fourth level is E14. So as is evident, the least amount of energy required is to jump from 1 to 2, and subsequently the energy keeps increasing as you go from n equal to 1 level to higher levels. The wavelength is related to energy as where c is the speed of light and E is the energy of the photon. Now, E12 will correspond to the longest wavelength. Lower the value of E, higher is the value of lambda. So, the energy required to make a transition from 1 to 2, since it is the lowest, it will correspond to a wavelength of the photon which is largest, or in this case, the longest wavelength. So, let's write down our formula. So, this we know that the energy level En, energy of a level, is given as n square h square over 8m L square. We can write the whole thing as C divided by n square h square over 8m L square. We need to make one thing clear, that the E that we have here is the energy difference between the two. This E is the energy difference, like 1 2, 1 3 and 1 4. So that will be equal to n square minus, because we have an n square, and then accordingly we also need to take care of the ground state, which is 1. So the longest wavelength is 1 to 2, corresponding to an energy level, or the difference in energy levels of 1 and 2, that is equal to C 8m L square over h square, and then 2 square is 4 minus 1. The solution of this is 6.87 when you plug in all the numbers into 10 power minus 8 meters. Then we can find out from 1 to 3 in the similar way, and that gives us 2.58 into 10 power minus 8 meters. So you see this is longer than this one, and accordingly, to jump from 1 to the fourth level, the energy of the photon needed is 1.37 into 10 power minus 8 meters. So the wavelength of the light keeps reducing, because as the wavelength reduces, the energy increases, and the energy of the photon will cause an excitation from lower level to a much higher level.